Hi everyone, welcome to ST Skills. This is a weekly system design session, and today we are going to have a mock interview. Ramya is interviewee, and I'm acting as a interviewer. So on alternate weeks, we also have system design deep dives. On like if you are willing to discuss or like participate, please feel free to join this weekly sessions. And with this, like let's get started with this mock interview. Um, Ramya. So today, we will design a service that will be part of the API gateway, and it will be used to control the number of requests that different clients will be able to um, access, like on an API.
Controls number of requests. Like, are you saying like a load balancer?
Not load balancer.
Okay. Like a
Um,
request proxy. Basically, if it is going to the service and service is controlling
yeah,
how.
basically, I just want to limit the number of requests each client would be able to access. I mean, like, or submit. So, like, let's say client A would be able to only submit 100 requests in second per second.
Okay. Got it. Okay. So some kind of a barrier or a decider which will say how many requests will reach to this service from the client.
Yes. Yeah. So our
Um,
API gateway will be forwarding the request to the actual service. I mean, so this component is just going to know like this client has only this number of requests per second or like per minute. So there is a time box window.
okay.
Within that time window, this client will be able to submit only so many requests.
Got it. Okay. So will that number of requests be limited based on certain criteria, or is it just first come, first serve, or is it up to me for me to decide? Is there anything that I should
No,
consider?
it's configurable generally. So what you can assume, like each client will have a different. Let's say client A, he will
Mhm.
have 100 requests per second, but client B is of different genre. So he may be or different premium type. So he may be able to submit higher number of requests, like 1,000 requests per second. So there is a difference between each client. So I'll say that for this client A, he'll be able to submit so many number of requests. So you can assume that is configurable.
Okay.
So in the API gateway. So yeah.
Okay. So who are we? Who is our customer? Who are we designing this for?
It's basically anybody who uses our API. So for now, like let's assume like within an organization, like let's take this as an example. Within organization, this API gateway would be used for different consumers, or like yeah, it's or in other words, I can say it can be anybody who uses my API gateway. Like if I have an external API endpoint, it can be external consumers as well. So let's assume like this is a public API gateway. So
Okay.
where we are offering some of the open APIs.
Okay. Got it.
Sorry.
And would it be? Can I assume like? For example, the number of customers would be in the rate of thousands or million, like just a rough idea, how many am I expecting?
For the scenario, let's assume 1 million customers.
Okay. And generally, per second, how many requests will I be expecting? So I need to group it, right? Like for example, I'm thinking for 1 million customers, 100 requests is probably too low. So per second, how much are we
Um,
expecting?
let's simplify this for a bit for now. So let's assume like 1,000 customers. So each customer will have different limits.
Okay.
So um, So you
Got
can
it.
take off 1 million. So we can expand this limit later.
Okay.
Um, so each customer, like the client who will be accessing an API that's part of API gateway, will have certain limits. So that is how many number of requests they can make per second. So
Okay.
e-
Some threshold number of requests
mhm.
for each customer per second. Okay. And how many, what is that threshold? It is decided by the API gateway or the client itself?
No. Client is not as a like owner of APIs.
Okay.
Who is owning the API gateway? We will control. So
Got it. And this decision is based purely on the number of requests, right? Nothing to do with functionality. Like, for example,
yeah, yeah,
uh,
yeah.
okay, got it. Sounds good. Um, okay. Um, so do I have to worry about any region or is it going to be global for now?
Let's assume this is global now. So
Okay. Um, okay. I think so I would like to start with the APIs so that I have a good understanding, so that we both are on the same page. You can help me out understand if I am going in the wrong direction, and then
mhm,
I want to start my design later.
mhm.
So just for the API part of it, I feel like the majority by the discussion, it feels like it's a post from the client. Um, so
It,
probably, yeah.
why do you think it is a post?
Um, So basically, we are saying that the client is
So,
going to reach.
just to clarify, so this APIs that you are talking about is the API that you are building for this new service that told, which is part of the gateway.
No, APIs from client. So basically, APIs that the client will access.
Oh, okay. It depends on what APIs we expose in the API gateway. So yeah, it's either way you look at it. So you can assume it can be any of those. So all HTTP methods, like we can have different. We can have another like the 100 APIs exposed as part of this. So each API is distinguished by the URI. So
Okay.
URI and the HTTP method.
Got it. Okay. URI and the HTTP method.
Yeah, that's how you identify like this is an API, and um,
Uh,
now you need to know like whether this client was accessed like 100 requests per second or not, like how many requests this client each client has consumed within a certain time period.
right. Okay. Um, I thought also the threshold need not be the same for each client, right? Like for example, if
Yes,
there is a client A, he can have 100 requests per second, B can have 1,000 requests per second, and so on and so forth.
yes.
And I'm guessing the number of requests per second has to do something with the amount of processing for each client, the
Yeah,
processing power. Um,
yeah, it depends on the processing power, like or the what kind of customer he is, like whether premium or not, and yeah, so multiple factors.
okay, got it. Okay, so I think I will start some low level design and then start trying to improve as we go ahead.
You mean high level design?
So
Right.
yeah, I mean high level design. Yeah, right.
And
Um,
just to make sure, like before you jump on to high level, so our service need to be very highly available
okay,
because the API gateway will depend on our service to determine um, how many. I mean, like because it's a very critical component in API gateway. So if
right.
this fails, we won't be able to serve any customers. So availability is of utmost importance.
Okay. Yeah, I forgot to clarify the non-functional requirements. What else? Do we need consistency?
No,
Eventually consistent is okay.
yeah. So what do you mean by eventually consistent in this scenario? Could you
Um,
elaborate?
Yeah, sure. Like for example, I am thinking that if the service decides that, for example, 100 number of requests per second is okay for a client A today,
Mhm.
and then for some reason, let's say it's Thanksgiving or something, it's a rush hour and the processing power is taking time. There is more competition, more number of people or something like that, and then for some reason the service API gateway decides that let's reduce the number of requests on each and every client, and it resets it to 50, let's say. So do we want it to reflect immediately, or for the next time the client sees, it should be okay?
It should be reflected as quick as possible. So, like if you have updated a configuration, so you can just like yeah, it should be reflected as quick as possible. So that's what I can say. So typically within minutes or so, or like even less than a minute. So
Okay, I see. um sure. So what I'm thinking is, so basically you're saying this is our API gateway service, and this API gateway service gets all of these requests, and he has to decide. Probably he's like the first boundary before our some processing service, right? And we are trying to design how this API gateway service itself will look like.
Not the whole API gateway service, just like a subset of this. So so this API gateway service will internally use this service that you are designing. So to identify whether he has exceeded the number of requests per second given his current threshold or not. So you can assume like this API gateway service will call your service internally
Mhm.
and
Okay, so I'm thinking there are a few things here.
Mhm.
One is probably some kind of configuration or decider service, decider of threshold, basically. This is where we will have some kind of configuration. Like this is the service which will say, for let's say for client A, the threshold is 100 the requests per second. For client B, it is 200, like whatever that amount. And this needs to be, say all of the clients, sorry, all of the clients should be able to access it for now, let's say. I am going to improve on the design as and when, like I just want to explain the main things that's going through my mind. So some kind of threshold, and let's say there, for this configuration decider, we need some kind of backup, where we will be storing for fast lookup and fast access. So I'm thinking it's majorly a key value pair. Like I don't see a lot of things to be stored here, except this is my client and this is my request rate. So I'm guessing.
so before like getting into cache and other stuff, so I still like where the API gateway went and what is this config decider threshold service.
So I am designing the API gateway service itself. So the different
Yeah, you can assume that API gateway service exists and all the clients will directly use API gateway. Like they only know about API gateway and they don't know about your internal service. So the API gateway will call your service to know by passing a client ID and like so you can assume it's part of API gateway, but like we are only designing the this limiter like threshold limiter. So
So I was thinking more in terms of, so instead of having this API gateway service do a lot of logic, I was thinking I will just divide it up into chunks and put it like different microservice level. But sure, okay. Mm. So you're saying make the API gateway service interact with all of the other things that I'm coming up with, right?
Yes.
Okay, I see. Um, okay, so one thing is the first thing that comes to my mind is this service needs this service needs to interact with some kind of cache because it's a key value pair like I was explaining. The key value pair would be basically client and whatever is his threshold. um, and
So let's can you
okay.
talk about like what data you are going to store for each client and what is the approach that you are planning to use to rate limit or like
So basically, I'm thinking it's going to be a key value pair. The key will be client name, and the client name, comma, the value is going to be whatever is his threshold. So let's say um, client A, his is 100 requests per second. Next. Sorry. If there is another client, client B, his is 200 requests per second, so on and so forth. For now, that is the only information that I'm going to store, but that is just for fast lookup. There will also be a database. The database is going to have all of the remaining values, like for example, um, what is the type of request that he is posting, what are the contents of that request, what is he exactly trying to do, and things on those lines I'm thinking. Let me know, give me a hint if I'm going in the wrong direction.
no, I think you're okay, but like so what information do you store like in a database and like how do you time box like this, how do you compute this number of actual requests? Let's say some request came to API gateway. How do you increment those number of requests within a time frame? So, what algorithm are you planning to use?
How do I increment number of requests?
Yeah, I mean, like in other words, like how do you keep track of the number of requests per second? So the seconds will keep going on, right?
Right.
So so as in you head to the next second, so your previous number of requests should not be counted. So you need to keep. So what is the approach that you are planning to use for this? Having correct number of requests per second at any point in time.
Well, that was the role of the config service. The config service not only fetches what is the right amount of threshold for this particular client,
So
uh,
yeah, let's talk
but
about this config service in detail. So what it does, like how it keep tracks of the number of requests. So that's a key component that I asked you to design. So let's talk about this config service in depth, like how it's going to calculate and keep track.
okay, so I was thinking this config service will.
Let's name this as rate limiter or some other thing, like for better understanding. So, or like it's up to you, like if you want. Mhm.
I see. Okay,
Okay,
got
can
it.
you talk about like how this is going to keep track of the number of requests?
Sure. So basically, I was thinking this memory cache, it can fetch from the memory cache every time a request is hit for a particular client and see what is the threshold. But along with that, I was thinking it should have some kind of internal way of seeing, maybe like a hash table or something. So for each client, how many requests came in. Every time a new request comes in, we will increment how many. So basically, I need two things. Hey, do you know how I can switch to the next tab? I'm not able to go here.
You mean the Google Doc or the
Yeah, the
direct?
Google Doc.
Oh, I think I don't know why.
Never mind.
It's strange. Yeah, in Chrome you should be able to switch right now. I don't know if you, since you are sharing, if that affects.
Basically, this thing is blocking my view. Anyway, doesn't matter. So what I was trying to say is, so these are the two things that I will keep in track, right? How many requests came in and how many requests are remaining. These are the two main key things. So every time a request comes in, I am going to increment how many requests came in and decrement how many requests are left. This is for fast lookup. I know it's kind of both are almost saying the same thing, but on the fly we don't want to compute every time. So these are the two main things that I would calculate and already keep, and every time keep incrementing. And I think I also need a queue or some kind of structure. Like for example, if we say there are 100 requests for a client, and let's say there are more than 100 coming in, we need to store those requests in some place. I was thinking like a queue or a streaming structure, a streaming queue structure, where after it hits that limit, we will go back and say to client, you're done for the day, but we can also store whatever he has sent, so that once his time is up, we will be able to seamlessly send that and complete processing. We don't have to limit the client and say don't send, or basically client will not see all those issues from the API gateway service. All he knows is he
Yeah,
sent some request. Yeah.
I think like I don't know, like, so in the requirements I told you to limit the number of requests, right? So it's a hard limit, so we should not allow like even one request beyond that. So in that case, like, how do you handle? So I don't know how
So,
the streaming is
so
going to be accommodated here, but like if you can expand on like how uh, what information you are storing. Like, let's take one request is coming. So what is the internal structure that you're going to use in rate limiter service to keep track of the count?
hold on. So you're saying that once the request is finished, like for example, the
No, we
100
don't
request.
track about finishing. So what is the main intent of our service is like the API gateway will internally use our service
Okay.
and see if this guy exceeded the threshold. If it is exceeded the threshold, then it's going to reject it, saying too many requests. So and if it is within the threshold, let's say within the 100 requests per second, so then we allow the request to be sent to the actual service.
I see. But isn't that a bad design? Like the client is going to keep seeing error each and every time. Okay, doesn't matter. Sure. Um,
What error? Like
so
this.
let's say client A hit 100 requests per second, but he's sending way more than that. So every time he hits 100, he's going to see an error saying that please wait for your next, like
It's
whatever
within
time.
the second, right? Like that's what we allowed him to access in the first place. So he should not be exceeding. So if
What
he exceed,
happens? What happens if he exceeds? Will he see like an error, a blue screen, or
yes,
is he just going to wait? Okay.
no, our API gateway should respond with 429.
Okay.
So like, I mean, like based on the decision given by this rate limiter service, which says that this guy exceeded the limit. So
So I see. So I was thinking of this is what rate limiter service. It can be a hash table, or based on the amount of request, it can be an in-memory cache also. Um, so basically have um, client, and the next one would be finished, 100 finished, 0 finished, and then he's all done.
No, but like, where is the time component here? Like, how do you know he's within the current second? Like, whether the current this request that you received, whether you're incrementing or decrementing.
Okay, I see what you're
Mm.
saying. So we need some kind of a timestamp component. Yeah, that's a good point. So how about we track based on something common? Like if I were to track based on client A and client to B, like each and every client's time zone, I don't know where they exist because it is already global. Maybe we can do like a standard time zone PST or UTC or something of those sorts, so that
We can take UTC. Yeah.
okay, so let's take UTC. So that way we know that everybody is on the same time zone. So some place we need to keep mapping. Every time a second is up, we need to come here. If it is a hash table, clear out the hash table. If it is a cache, then we have to invalidate the cache. The easiest way is maybe we can have like a TTL going on, and we can set that TTL, at least according to the current discussion, TTL is going to be 1 second. But as and when the requirements change, we can change the amount of TTL. So every time 1 second is up, basically just clear it out and set, basically how it will happen is this will go back to the original condition 0 and 100. So this also means that we need another way of tracking. So this happens to be one data structure or cache, right? So we also need another kind of thing. So basically we need to say which client has what threshold. So if the same service does all of this tracking, I think it might be too complex for the same service. So maybe we can have like another service purely to fetch this.
I think I lost you between.
Are you able to hear me?
Yeah, in between you got cut, so I didn't catch.
Sorry. How much were you able to hear?
No, you started with. I mean, like the second option, which client was you were about to talk.
The invalid. Were you able to hear the invalidation cache part of it?
Yeah, yeah, yeah. It's
Okay.
just I think this fetch threshold service. Why we need that? I don't know.
Okay. Okay, so the main part of fetch threshold service would be just to fetch threshold. This is because let's say after 1 second is up, right? I need to reset, like I said. So for A, the number of threshold served will become 0 and number of requests remaining will become 100. So this basic reset, right? Let's say for B, it is going to be 200. So how do we know what is the actual value? So this actual value is where it is stored in cache, the cache that I was
Yeah,
talking
yeah.
about.
Yes, yes.
Right.
That's fine.
Right. So I was thinking if the same service is doing both of these things, fetching and also updating this particular thing, then it might kind of become complex because these two are not related to each other. They can happen in parallel. You can always try to fetch while you're doing something else. So I thought we can just split it out into another service.
Cache you don't need to fetch, right? Like it's already like available. I mean, like it's as simple as get from cache. Like it's like a hash table only, right?
Yeah.
So what additional thing are you talking about fetching?
Sure. I was thinking in my mind that maybe we are going to have a global cache, like a Redis cache, but sure, yeah, we can do that also. Um, so apart from this, what else is remaining? So you said we don't need any sort of queue because we are just going to limit the whole thing. So then the another thing that I can think of is
No, I still didn't catch the fetch threshold service. Why we need that? Because we want to limit the number of requests already, like, and why do you want to introduce another service here?
Um, yeah, like you said, if everything is in memory, then we don't necessarily need that service. But if it was like a global cache, some process or something has to go and fetch if it is in the same service, right? So I was thinking of moving it into another service, but let's keep it for now as a separate process in the same service.
So let's talk about like how you are handling this, how you are going to reject. So can you expand on the data structure, like how it's going to store the number of requests and like the algorithm, how you are planning to reject a certain request, or like how do you determine this guy exceeded?
Um, I don't think.
Like the algorithm, let's say the number of requests, let's take some examples of timestamp, and let's can you add a sample timestamp to this A and B?
Okay. Mm, let's say it is November 28th. Let's say 9:30 in the morning, 9:30 a.m. So until 9:31, we are allowed 100 requests, right? So
9:30. Yeah, I mean like you have minutes. Yeah, let's. I mean like even taking a minute is okay, but uh,
oh, yes, a second. Okay. Okay.
so let's say some requests came at like within 00 some. I mean like instead of milliseconds, we can take it as a minute now. So
Okay.
let's say we have this rate limiter per minute, and within 9:30 some other like 10 seconds or 20 seconds, like you have keep requests coming, and I just basically wanted to understand a little better like how
So
at what.
basically, I will just keep what all tasks are there for me to monitor. One is somebody has to request the process that will process the request that comes in. Um,
No,
and
process is not in our control, right? So you mean the incrementing the counters?
yeah, basically modifying this data structure
Okay.
limit. Yeah, when I mean process, like that's all the processing we
Yeah,
have
yeah, yeah.
capacity here. Um, Something else to keep track of time, like a timer. I wouldn't say timer. Timer is probably not the best thing here, but basically some kind of timer, something along those lines, which will keep track once the 1 minute is up. It has to notify us, saying that it is up. And the resetter. So you want me to elaborate on how I'm going to keep track of the time, the second part of it?
Yes. So like what are the challenges that you face in this? Like so at in other words, like at 9:31, like what happens? So if we take 1 minute intervals for rate limiting.
So firstly, if there are multiple processes, I don't know how these clients are coming in. If one client is going to be only one single machine, or is it going to come from multiple machine? Like if client A, if there is anything between client and the service gateway API, like for example,
So
if
I think yeah, you can leave all that because like you already know this request reached API gateway, and your component is already part of API gateway, and I mean like so you can assume that the API gateway is internally is using your service to keep track of this number of requests. So so basically, I just wanted to expand on that previous number of requests, like in an example. It's like not kind of an algorithm how what happens. So Are you going to use like a fixed window or rolling window?
I see. Okay. I see. So I thought I'm just going to reset it, but I think you're mostly asking me, like, I feel like the examples that you're giving is pointing me more towards a sliding window kind of solution, where every time so for example, 1 minute is up, you just slide over to the next minute and say, okay, now what is going to happen. But I was of the impression that I am just going to clear out the cache. I don't need these windows, because I will just flush out everything that's there.
So like the challenge of, you mean the fixed window approach, like at the end of 9 30 59 seconds,
Okay.
you're going to flush out that client A entry and
So
use
exact
it as
no, so I mean, like for 9:30, like the last second, not even the last second, as soon as it hits 9:31 a.m., I am just going to flush out this table. Some new process, like maybe this reset process is going to come and say, for this client A, what is the threshold? It is 100, so it is going to set 0, 100, then 0 to 100. Like it's going to reset everything one after the other. The main challenge here would be when this reset is happening, if there is a new request coming in for that same thing, how are we going to do things? Like basically, for the same row, how are we going to lock it is what I think you're leaning towards. I feel like it. So maybe we need to because this is a hash table, right? We don't necessarily have to limit the entire hash table or the whole cache. Like you can set a lock per row, right? So if A is trying to flush out, or let's say B is trying to flush out, B is trying to set that you are at 0 now, and your total number of requests remaining is 200, and now A is coming in and saying, I need to do something, right? Maybe a get or a post. We can just directly go ahead and increment this. We don't have to limit him, because these two are mutually exclusive. Just because A is having a right, I mean, A is having some operation, doesn't mean B cannot function. So what I'm trying to say is we can put a lock per row, not the whole table or not the whole structure itself.
okay.
Is that what you were mostly leaning towards, or is there something else? I
No, I
need
was
more
just
example.
checking to see like whether you know like how what you meant by like a sliding window, like how it's different from the approach you are talking about now. So which is a fixed in window approach. Looks like.
Not really. I don't. Yeah, to be honest, I'm
Yeah. So with the sliding window, what happens is with 9:30 and 1 second
okay.
to 9:31 and 1 second, there will be 100 requests per second. So
Okay.
9:30 10 seconds
Okay.
and 9:31 10 seconds, between those two you still need to maintain 100 requests per second. So this is just to make sure that like just at 9:30 sorry, just at 9:31 and 1 second again client can send 100 requests. So it's just to limit those traffic to our services. So I mean, like it's okay, but at this point you are explaining is a fixed window approach.
I see. Okay.
Okay, let's. Okay, do you have anything to cover in this rate limiter service? I mean, like the algorithm or anything.
Um,
Do you want to talk about edge cases here, like what are the challenges and how you plan to address within this?
sure. So a few edge cases. So obviously, if
Assuming
everything,
you're, yeah,
go ahead.
yeah, assuming you're using the fixed window, or like if you want to switch to sliding window, you can explain that also, how you're planning to handle. Or like if you proceed with fixed window, I want to know like what are different cases that you're that you need to be aware of?
Um,
Or
yeah.
like how do you reset only this? Like let's say this reset logic. How do you keep track of how do you hold a lock on a specific entry in hash table? Because you said it's a hash table only. Is that possible?
Um, yes. So you can lock per row instead of locking the whole hash table. Or so let's say if client A is coming in, so it's 9:31 exactly, and there are two things that is happening. The reset data structure is resetting for the hash table, and it is at let's say it is at client B. So it doesn't have to stop client A from coming in. If there is a request by client A, then we can directly update the row in client A and let it proceed, is what I was getting at, because we will be locking just this. If there is a new request from client A at the same time, if there are two requests together, then we will not allow it. But as long as it's from another client, we should not have that issue. That's what I was getting at.
Okay. Can you come again? So how? Mm, I think I missed how you. Can you repeat what you said just now?
Basically, I'm just saying the same thing again. So the lock will be set not on the entire hash table, but per row of the hash table. In this hash table, A is the key. In the next one, B is the key. So on and so forth, right? So when an operation is happening on B, we don't have to limit A. Similarly, we don't have to limit C if there is a C. So they each operation can go in parallel for each row is what I was getting at. So if we are trying to reset what is happening in C, we don't need to limit if there is a client A which is coming in and saying coming in with a request, right? We can always decrement it and get the like let it allow to process through in the chain wherever it is at. So we the API gateway service doesn't have to limit it.
Okay.
Yeah, yeah. I don't know. Those are the only things I had. Um,
Okay. Let's switch to the high level diagram.
okay. Yeah,
So
I
are you using a database or just the hash table? So that is something which was not clear to me.
so it
In rate
depends.
limit.
So
Oh,
for now, I think we, at least according to the requirement, we don't necessarily need a database because we are going to try to invalidate the cache and then just flush out the request. But for some reason, if we needed a more permanent store, instead of, as soon as we invalidate the cache or flush out the hash table, whatever that is, we can just move the entries to the database. For now, this looks like it is out of scope, but I'm just putting it there that in case we need
okay.
to extend it for some day, we can do that. Um, so there needs to be in the rate limiter service itself. Uh, yeah, I don't think there's much.
Yeah, maybe you can just walk through a request and see like how it works on end to end. So let's take, uh, let's say client one is sending some requests.
Okay, so
Uh,
let's say client one is sending a request. Client one sends a request to API Gateway Service. Let's say he's posting some content, and API Gateway Service will in turn give that to the rate limiter service. So the rate limiter service has basically two tasks to do, right? One task is obviously, I think it needs another cache also. One task is obviously to go to the cache to find out what is the threshold for this particular service. What is the threshold for client A? What is my threshold for client B?
yeah, you can assume anything like 100 or something. It's okay.
What is my threshold? And once it gets back, what is the threshold? It will
I think I'm losing you. I don't know if it's my issue. Can everyone hear Ramya?
What about the second data structure, this data structure? We need another data structure like this. Either we can have it in the same, hello?
Yeah, I think there is some lag in the, whenever and you're cutting in and out in between. So
Okay.
mm,
So we need two tables. Just for simplicity, I'm putting it here, but we can have it in the same cache as well. The second table that we need is basically that data structure that I was talking about, like based on what is the current, like let's call it as the stat table. The stat table is nothing but this table that we were talking about, the client name, number of requests remaining, and timestamp. So this is what I mean by the stat table. So we are going to increment the stat table or decrement the stat table. So we'll increment how many requests are served, decrement how many requests are remaining, and give it back to the rate limiter service, and let it process through and let the client go through to the next service. So whatever the next service is, right? I think API gateway service is like the limiter to the next service. Let's say this is the actual service A that the client is trying to reach. So once all of this happens, we can we can route this particular request to service A. I'm just assuming it's going to be service
yeah,
A. This is probably not where client is trying to hit. I don't know if it's an account related transaction. Let's say this is some kind of account service that he's going to. So we will let him go through to this service if he's well within the threshold and everything works out.
okay.
Yeah. Yeah, this is kind of
Uh,
a, yeah.
okay. Yeah, I think end-to-end flow looks fine. So do you want to wrap up? I think we are at time. So
Sure. Yeah. Not much to say about wrapping up. Like I know we walked through end-to-end flow. This is one of the tough questions that I've come across. I would like to go ahead and see, discuss further with you how we could have solved it better. I know this is not the best solution, so yeah, looking forward to it. That's all.
okay. Thank you. And let's now open it up to audience and hear feedback from them. And I can also give my feedback at the end. So thank you for participating, Ramya.
Thank
Um,
you. Yeah, of
yeah,
course. Yes.
yeah. Anyone from audience want to share any quick feedback?
Hey, before the audience, I just wanted to give a good feedback for you, Naga, as an interviewer. I think you did a very good job, a fantastic job, actually giving a lot of hints for me, and unblocking me when I was
Maybe you
lost.
can.
Yeah,
Yeah, yeah, no problem. So
Hi, guys, can you hear me?
yes, yes, correct.
Mm. So, first of all, Ramya, I would say great job that you kept going in spite of, like you admitted, it was a difficult problem. So, it's really good that you kept going and kept trying to look for solutions for the questions that Naga was asking. So your persistence is really admirable. So really keep that up. In terms of feedback, I think you understood that a bit when you were already deep into the problem, that you probably had a different understanding of the problem than what Naga was asking. So, and interestingly, this was the same thing I faced yesterday when I had my mock interview. So, lesson I learned, and I will just pass it on, is be 100% sure that you are clear in terms of the requirements. So before writing anything on the or drawing anything on the whiteboard, explain exactly, okay, this is exactly what my service will do, and is that correct based on your understanding? I think what you started to design was somewhat different than what was intended. So I think that's my main feedback.
Yeah, thank you. Yeah, that's a good feedback. You're right. Yeah. Yeah, I feel like it was one of the tough questions, and you're right. I kind of got lost in between. Even in the beginning, my understanding was kind of away from what the question was. But next time, I'll try to get everything done before I start, like clarify the question first properly.
Thank you, Kartikeya. Anyone else? Ramya, please keep sharing the screen so that like
Oh,
audience will have some context. So
definitely, definitely.
yeah.
Um, yeah,
Thank you.
of course.
Anyone else? Praveen? Drupat? Don't know why everyone is silent. Alex? Just randomly asking by names. Can you guys hear me?
Yeah, I'm able to hear you.
Okay. Okay. I don't know if everyone is silent. So, Asim, are you there?
Yes, Naga.
Do you want to share any feedback? I'm not hearing anyone
So
speaking
I
up.
I
So,
don't have, I think, much feedback for now. What I will only say, Ramya to practice more if she's going actively looking for. And so I think this could be a good exercise to see how you can train your thoughts and switch between. So my feedback is on the logistics, like how you can well play with these things. So I will recommend if you are not so comfortable with bringing these blocks, then try to use a pen or something and see how you can switch between your requirements and this diagram. Or could be like if I would be there, I would copy all the requirements from the Google Doc. So first I'll take on Google Doc and then I could bring it on this draw IO in the text box, like copy paste. So I don't need to switch back and forth, and I could validate all the requirements what I am doing. So if you are actively looking, then I would say like uh, think how easy or difficult was this session for you,
Yeah.
and see, because everyone would have their own way of doing things. I would prefer something else, and you, so I think this is a good exercise and you have volunteered for that. So that is, I think, a good move in that way. And because these days things are different. Earlier it used to be total whiteboard session 101 in a room, but now everything is remote, so we have to think in that way, like how to present our thing. And system design itself could be really extendable topic. It could go in really different directions, so need to see how interviewer is thinking. And then you did a good job, like where you are asking Naga like what direction you are doing. And it could be a total, I could see like if this is an unknown situation for me, unknown topic for me, I would have zero clue what the interview is expecting, and it could be something which I have not used in any day to day my work. Then it is again a challenging situation for me. Like, hey, what is the use of that? And then you started well, where you have started what are my customers, where what are my requirements and things. And but I could see like more practice is needed, so the thoughts should come natural, and that could definitely help you in any real time interview. So idea what we are doing here is practice here, and then when the real interview comes, then all these things could be trained well, and then it's a win situation in a real interview.
Sure. Thank you, Asim. Yeah, it is a very good feedback, and you're right. This was a totally unexpected question, and yeah, it was evident. Yeah, I am not actively looking, but I want to at least like brush up my basics, and kind of
Mhm.
as I grow in my career, I think designing is very important. So
Mhm.
this is a very good platform for me to learn more and kind of get ready, right? So I thought this is a good opportunity for me to jump in, and thank you for this opportunity. And your feedback is very valid. I will take it into consideration.
Okay, thank you.
Thank you, Asim. That was good feedback. And
So if nobody is there, then Naga, you can share your feedback, and then if we have time, we can see if we have to do this design little different to what we could do.
Yeah, I think I would like to see that. Yeah.
okay, let's see if anyone else opens up now. So
I think, Asim and Karthike already covered the main point, and as Ramya, though you really did the great job, and there were some point I felt that you were a little bit shaky, but you managed well. But I think the key part here in the system design, what personally I feel that the requirement gathering, and I do the lots of mistake during that time, and jump to the solution immediately without understanding the problem correctly. As this for this particular problem, Naga mentioned that you talk about the global, and John Wise and Naga mentioned that global, and with the global, this problem is really difficult now, because now you have to actually think about that how will you actually synchronize your counter um, uh, across the geographical location, different data center. So there may be multiple ways now you have to talk about all these trade.
Right.
Yeah.
Yeah.
And even for solving this problem locally, so there are multiple ways to solve that problem, and so like Naga gave you some hints, so like whether you will use the fixed window or rolling window, that kind of thing. He gave you the hint. So that and that type of hint you will get during the interview when you will stuck. So interviewer will definitely give you some hint, but that's your job to actually grab those hints.
Got it. Okay.
Yeah.
Thank you.
thank you, Praveen. Um, anyone else? Okay. So if no one else is coming up, like my feedback is also like on the similar lines. So on the requirements, I see that like couple of catches is like on the functional requirements, like I maybe like you could have asked like little some more questions to make it more clear, like what component we are designing, but like you came back to that like in the middle, you actually understood what I was actually asking for.
Mhm.
And the non-functional, you jump to the high level diagram and without asking for non-functional, but like I know you realized that you missed it after I told about availability requirements.
Right.
So so that is one thing. And yeah, it's mainly like I think if you had understood, maybe you would have started like little upfront, like better. And the other key thing I was actually looking for was like um, I mean, like as I was trying to push you to how you keep track of the counts. So that's where like it's the main functionality of this service, right? So how
Right.
you keep track of the counts for each client, given like there could be multiple, like it's all concurrency. No, uh, I mean, like the each client can keep sending requests, and if you are using the same hash table, so
Mhm.
you said that you could lock an entry, but like I don't know. I mean, like how it can be achieved. Maybe it's possible, but yeah, I mean, like since you said lock, maybe like it's okay, but like I didn't know how the lock can be done on a hash table. So that is something maybe I don't know, but like that concept is at least okay. Like each row, if you are trying to lock to make sure that you are not updating, and I was trying to push for rolling window, but like and I was okay with even other approach of fixed window, at least to come up with a solution.
Right.
So mhm.
Yeah, I think I should go and brush up on the basics, at least about rolling window. And like I don't really, I am not at least familiar with the terms. So this is
Yeah,
a
yeah,
um
term is just a thing, but like it's basically over a period of time. There are like many similar problems, so
mhm,
which you need to compute over the period of time. So how you keep track of these counters is commonly occurring problem in many different system designs.
okay.
So and I think the high level block diagram is okay, and I don't know if I missed any other thing. So the yeah, as I told, like the key thing was like how you handle that concurrency and whether you'll be able to come up with um, this sliding window or rolling window, both are same. And
Right.
this yeah, that's the main thing I was actually looking for. And yeah, maybe once you brush up, you may be able to talk better and explain better. But I mean, like given the time and you didn't know, you did your best. So
Yeah, thank you. It was a good
mm.
question. Something I didn't expect at all. For
And
the
I could have asked this as a simple design and API rate limiter, but like I wanted to ask this in an indirect way. That's why I went this route.
right.
So,
Yeah.
so yeah.
Yeah. Um, Yeah, I mean, after all the feedback, I would also really like to see how and like how you or another experienced engineer would have designed it, because I'm sure there's a lot of gaps in this design. So I'd like to know how to do actually how to approach this problem.
I think we did this sometime in the previous, I don't know, sometime back, right? A same design an API rate limiter. I don't know if you can, or was it a mock interview? I don't remember. But like, so ideally, yeah.
That was a mock interview. I don't remember. It was with the. It was I think Abhishek or Nisha. I don't remember.
I am new to this group, but I will, yeah, I that's why
So
probably
You
I
you
should.
should
can
have a
refer back.
previous recording.
YouTube channel, right? Yeah, I'll definitely do that. So for that hash table thing, right? I was mainly leaning towards something like like a concurrent hash map. So those kind of tables you can lock per row. So, but I totally missed the increment and decrement part of it. I know you were pushing towards it only now when you
Yes.
were giving me the feedback. I realized I forgot about that part. Yeah.
Yeah, basically I was actually looking, like, given a certain time, some examples of how you increment and
Right.
how you when the time comes, how you basically, if you are using the sliding window, you need to decrement the previous request counts in the previous times and like previous seconds. So, but like if it's a fixed window, you keep like, yeah, once you aggregate all the counts for that time frame and you discard, you reset to 0. Yeah, that's the approach for fixed window anyway. So mainly, like, if you want, like, I can actually share or like you can even refer to educative. I think it has API rate limiter to see, like, it has different algorithms explained also.
Okay.
And the sliding window is a, I mean, like, common technique in coding also. Like, if you know about that, like, it is similar, but yeah.
I see.
Each window, I mean, each slot on the window represent what, second, minute, or hour?
Yeah, you can define that as well. So generally, like, it's per second in this world, at least as far as I know. Like, you can even go to granular level of milliseconds, and you can even go up like per minute or per hour. So yeah, you can configure those in normally in an API gateway, I think.
But if we go with the second, wouldn't the window getting bigger? Depend on the granularity, right?
It depends on how many number of requests or how famous that API is. So let's take if it's a weather API and it's very used by millions of clients, and so you definitely can't go maybe like a larger. I don't know if that's a bad example, but like let's take that's a very let's take a price service. So price is something that you normally use very often in your retail system. So any service, if you take an example, whether it's very used by large number of people and it can have large number of requests within per second, then like you need to reduce your time window. So instead of second, it could be milliseconds also in some cases. But usually, I think second is good enough to control most of the services.
Yeah, one thing is, like, instead of based on the hour, I mean, based on the slot, let's say in this case, every second we're going to decrement or increment, change the window. We can leave it as until a new request come, right? If there's no request, then we don't need to do anything. But there's a new request come, then we will adjust the window. So that way we don't need to spend time to adjust, every second for every API endpoint, right?
Can you repeat that again? I didn't catch the last sentence.
So I think in one of your, I think before you were mentioned, like probably like you wait for 1 second or something, and every second you go in and you increment and decrement the window. I mean, you adjust the window, right? Every second.
Right.
What happened if in that second there's no request, nothing, coming in? And
Right.
what I'm saying is like,
So we don't do any changes, right? It just whatever is there will remain. If
Yeah,
there
yeah. There are some strategies, like if you explore, like you can just like store the last timestamp. You can keep storing the counters or like the request. Sorry, the client ID and the last timestamp the request received, and The first,
or we don't even need that, right? Like for example, if there is no change made at all in that one, let's talk with respect to minutes, just so that it is simpler.
Mhm.
So in that 1 minute, let's say no request came in and no request, nothing happened for client A. We are just going to let it be as is, and anyway,
Yes.
in the next minute, we are going to clear out, flush it out, right? The cache or whatever, the hash table or cache, we're going to flush it out. So it shouldn't really matter. As long as there is no activity, we don't make any changes to the cache. Does that not work?
Yeah, yeah, actually the only thing that you need to worry is like making sure you reset to 0 when the time, if no requests come, like
Yeah,
just
that's
clearing out the previous one, that is key. But like
mhm.
if it's 0, you don't need to do anything if no request is coming. So you
Right.
don't need to again reset or redo some of
Right,
the
but
things.
if you need like a simple, like if we don't need so much of, we don't necessarily need so much of logic. I'm thinking like whether it is 0, whether it is 10, no matter what the number is, just go and reset it back to the original amount, right? We don't even have to think about it.
Yeah, I think I don't know if where the fixed time window makes sense, but generally, like I think most API gateway may be using sliding window,
Okay.
because fixed window has some like hack, like within, if you take about minutes, then the 59 you can send, like if 100 is the limit, 100, and then another just in the, let's say 9:30 59 he sends 100 request, and 9:31 1 second he can again send 100 request.
Mhm.
So that 100 can be 10,000 20,000. So within those 2-3 seconds so many requests come, and your server may not be able to handle so many requests.
Got it. Okay.
So if, yeah, so for those scenarios I think the sliding window is more used, as far as I know. And for sliding window, yeah, I mean, like you always keep track of that 60 seconds, like if you take a window.
Okay.
So in the modern API gateway, the rate limit service will be done by the APG or something, right? At least
Yes,
most of
yeah,
the
yeah, yeah.
limiting.
APG or like any API gateway will have this capabilities. You should be able to throw, I mean, like it's another way, another term is throttling, rate limiting, or like both are similar. So yeah, we can specify this client. You can configure like it is not just for per second. You can say per second 100 requests, and you can say per day like 10,000 requests, and per
Mhm.
month you can still say 1 lakh requests.
Yeah, when we
Mhm,
configure APG
mhm,
gateway
mhm,
during the proxies, we actually say that we'll be
mhm.
getting 20,000 requests per second or
Yeah,
something, and then they
yeah,
will automatically scale out and help us get the traffic in at the right
yeah,
place.
yeah. It's a key service because that all API gateways should have, because like there are like so many malicious users, so they just simply want to bring your reputation down. So they just simply keep sending fake requests. So if you don't have this limits, your server will be screwed if it's a public
Yeah, denial
API.
of service attack,
Yeah,
DOS attack.
that's a DOS attack. Yeah.
Yeah.
So
Is that
this
the rate limit is based on per user ID, or is that based on like per uh,
yeah,
API
it's
or per
multiple.
method?
Yeah, it's mainly the client ID, and you can also drive by IP address. So common
Actually,
is the user.
even before gateway, there are some more layers like WAF layer or some security layers, where also they do some kind of, in every team, like every company has a security team before it hits the API gateway. Even they do some kind of rate limit testing to prevent attacks like IP address attacks from
Yeah, so I think,
non-use. So if you're a Indian customer or a US customer, you're getting transactions from Nigeria, or like Pakistan, or some kind of like Uzbekistan or someplace, then Korea, then they will actually filter you off. So some kind of filtering is done, and then throttling is also done at security layer and then also API gateway service layer.
Yeah, generally like where API gateway is not there, so this proxy servers or reverse proxy also has this capability wherever they're using that. So they will also be helpful in filtering out those.
But I still think limiting at that having that limit thing on the service level is faster than having a common component.
You mean like, but like the network, you mean like you let the request go to the service and service decides?
Yes.
But
So
if you are in a big
fastest
corporates, right, Asim, is that Asim or
Yeah.
Yes.
yeah? So Asim, if you are in a big corporates, right, so you have thousands of services, so you have to come up with an API gateway so that across the board you're using the same kind of a benchmark. And so generally they don't use service throttle service, they use a third party API gateways, so that either they use this
Yeah,
or they use
I think, yeah, one another general observation why it's not done at service level is like your service may not be directly from the API gateway. Another service would be maybe invoking you. So this in a microservice world, this can be a chained format, right? Like one service calls another service that calls another service that calls another service. So if
we did use in a rate limit service for our internal service within the DMZ, like where we didn't want to use queues or anything. In that scenarios, we used rate limit service to internally call services, and
So
one application internal AB inside the network calling services.
so there are two things. We are talking about two things. One is API gateway having this rate limiter logic, right?
yeah, or other component. Yeah, it can be, yeah,
Yes.
even service can have rate limiter, but like it can also deny the request still, but like.
So the thing is, most of the services, what I have seen in my past experience, every service comes up with its own rules. And then API gateway, I don't know how it will configure customized rules, but my service can tell, okay, this is a service, this is our rules. When the service is boot, whatever the component it is doing, common component, it will load that rules. Then the trick is all the service instance have to talk each other. But if we are using some common technology, it could be doable. But the only thing is, I think it would be really fast when it is at the service level. Otherwise, rate limiter talking to some other component could have its own latency.
Yeah, basically, yeah, though I said it's a different service, but typically API gateways internally have this component. So it's not an external service, just for the sake of latency, I think. So it will be part of API gateway service design. But like since
API gateway would again be distributed, right? It
But I
would
think
it cannot be like one thing. It would be again be distributed. I'm drawing, and then again the service could also be distributed. So the API gateway would have like additional responsibility to figure it out a lot of things. So if I have a lot of customized rule, then it has to even load that customized rule. And like say I have that rule somewhere in S3, so it has to go and pull that rules for me. And if I change that rules, it has to update that rules also.
I think,
Yes.
I mean,
So generally
I'm
what
thinking
we do
from
is, if
different
you are
point
using
of view.
API gateway, all the rules are also configured in the API gateway only. So
Agree.
it doesn't have to.
I'm thinking it from different point of view. If you actually tightly coupled with the service itself, so that will actually increase your maintainability.
But if you have like microservices, right? You call one, microservice, call another, and how how do you know who your client, who your really client, who's the internal client?
Any service cannot call other service without any header or payload. So there would be always some rules on some headers, or there would be some star rule. Okay, if couldn't figure out, then there could be some star rule.
Yeah, generally, like in the API gateway, like for each method, like you have, I mean, like for each API, you have an URI and get or post. So that, I mean, like, it's like, in other words, endpoint in API gateway where you can set these limits. And as a service, if we want to utilize API gateway, we proxy the clients to go through the API gateway before hitting us. So we don't directly expose ourselves to outside world, and we only give the API gateway endpoint that we configured for our service, and that's what clients are going to use. So the only API gateway knows to talk to service A, and this communication between API gateway and service is internal to the org which is owning that service. And API gateway is like public. It could be like depending on where the clients are.
API gateway could be serving a lot of services. So
Yes. Yeah, not
so
just ours.
there would be service B. So this guy's serving here and this. So uh, I am just discussing it for the sake of we should have two different perspectives. So I don't have any reservations on anything, but the reason why I'm trying to bring it, let's have there are two different things. One we could have here, or either we could have here. Then let's see what could be pros and cons. Here I could see the thing is before reaching out to the service, we can take a decision.
Yes.
Right.
Yeah,
But,
you don't overload the server if you define in API gateway. But the advantage in service, I mean, like implementing in service here, maybe it's simpler because it only needs to keep track for it. But
and for some reason I want the rules to be changed. I have to just redeploy this service and the rules could get changed. Or if suddenly I don't want API rate limiter, I just can remove the setting from here. But here, this is a common component shared across services. I feel if something is very common to all services could live here, but if it's something very specific to service should live here.
So Asim, even though it's a common framework, each service will have an individual configuration at the API gateway level. So even though it is specific to service A, the configuration for that is very specific in API gateway service. And you can tweak that and bounce on. Actually, you don't even need to bounce if it's a config, right? Especially for APG gateway or something. Automatically, it will pick up the next configuration. If you say 1,000, then you say I need to, like for Black Friday, right? We had to change one service from 5,000 to 25,000 transactions per second. So we just made the change. Next minute it goes, looks at the config, and it automatically changes it.
So that means if I have 1,000 services, all of these configurations would live here, right?
Yeah, all the ones will be live at the API gateway. Yeah,
okay.
And you can make the changes there.
So if I have to change how this change works, like it's a CI/CD?
You can do it as a CI/CD for auditing purposes, and sometimes if we always have a manual switch where you can do a command line or a dashboard. You can also use the API IPG UI to make changes.
So as a dev, I don't want. If I want
then you can use CI/CD. Yeah.
If I only want to change for service A, I don't want to go a common component where all the
you can just change that for service A.
No. If either CI/CD or manual, still any component which is serving a lot of things, changing for one service, I don't want to keep on changing that guy. It could bring down that guy, and then it could bring down all my services. That's what I'm trying to say. Any common component serving all services and touching it frequently is not, I feel, a good scenario. And we have seen like 2-3 days ago, there was an outage in AWS. There could go things really terrible wrong when one common thing goes down.
Yeah. So basically what happens is here is this a framework, right? So one is framework, one is individual service configurations. So frameworks, it's like what happened in AWS, right? Amazon, that is something completely different. Like it happened in Azure also 2 days back. Azure also had an issue. Their buckets had some issue. So that impacted lots of Black Friday sales across the world. Black Friday, not this Thanksgiving sales. But
even one of my product also got impacted because one common component went down. So that's why
yes,
we always try to say like separation of concerns. That one guy should do one job and then other guys do their own job. So in that way,
yeah.
one so that should not become the single point of failure. So that's what I'm trying to say here.
Yeah, actually, even in API gateway, right, there are multiple things that at least we use FPG. So FPG can do multiple things. So they have different components in them. So it's not one box, but they have authentication box. They have rate limiter box. They have different things in the same um, thing. But what happens if you use this rate limiter service, right? No two teams, or no, you may have do that in hurry and you may not have implemented all the best practices, right? Some, or you may have code reviewed it but forgot something. So when you're using enterprise wide, you should be careful of what services you're using and how it's being consumed. It may work for lower threshold but not work for higher threshold. It may work for higher threshold, but it may not have satisfied all the security concerns. And one security vulnerability will bring the whole company down and in news. So you have to be very careful when you're writing any custom service which is used by external world, or which may expose a port or vulnerability or some data.
So I'm not that, yeah, so that's what I was trying to say. I'm not that big fan. Any common component is serving a lot of things. Changing it frequently for a service specific demand is looks like not a good idea. And whenever it is manual also, we don't have any audit and track who did what.
Yeah, everything should be audited, especially in production. Everything should be audited. Which login ID updated, which configuration, what time. And there's always there should always be a rollback switch whenever things like this. You should try it in blue green deployment before you actually make it live.
Okay, back to the rate limit. I have two questions. The first one is like, are we throttle the request based on whether the request will be successful, or we only throttle based on the request? We don't care, if this request going through some internal service and it fail or whatever. That's my first question. And the second one is, how do we handle the global throttle? Because each, we could have multiple API gateway at different location, right? How we globally enforce that global rate limiting?
Leon, I didn't catch what you're saying.
So Leon, what you're saying is, how do you distinguish IP addresses that comes from different areas of the world, right? And
so my first question is, when we throttle rate limit, we rate limit on the incoming request. And, because the request could be, it should come, right? And we don't know if we can serve the request successful or not. Are we limit on like when it first come, and we will count increment, do the adjustment of the window, or we wait for the result come back, and at that time we're gonna do it? That's my first question.
Result come back means if you have a limit of 100 and and you have 50 transactions, only after the 51st transaction is complete, you remove it. Is that the question? Or
I think his question is that when the request comes, so if that request fails, so do we count it against the user quota or not?
Yeah, because it could be asynchronous, synchronous, or something, right? But it could like we pass through the API gateway, and then when it come out of service, I say okay, it not meet the requirement or something, and it return fail. Are we counted at one single request?
I think what we were discussing so far, that is actually based on the incoming request. We don't care about whether request succeeded or failed.
Yes. So at the API gateway, you don't know whether it fails or not, right? So
But that's a good question actually. But
Mhm.
I think if you consider the fail, that will make problem more difficult then, I believe.
though
is there
API
any
gateways,
limit in the quota for each client that how many he can send?
you mean batch or single? Or, don't know.
No, like a client, one of the client can only request 10 transactions a day, right? Is there any limit like that or no?
Yeah,
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 that
that's a rate limit, right? That we are talking about.
That's a red. Okay. In that case, yeah, every time the request comes, we'll track that. Probably we have to create a separate table or something.
Yeah, that is the stat table that I was mentioning. Like,
Yeah.
it will have what is the client name and how many requests came in, how many requests are remaining to hit the threshold. Yeah, things on those
Yeah,
lines.
irrespective of success or failure, the transaction came and it will be counted against it.
yeah, that's what we were discussing. And his second question was, I believe, that regarding that the distributed global counter, or
Yeah, it should be like if our service is global, so API gateway, it will be global. So
all the requests have you come to the global one?
so it's again like how you configure this API gateway accordingly. Rate limiter also will need to be designed.
so the one solution to that problem, I can think about that for a particular user, route all the requests to a particular data center only. So
Yeah, I mean, like if that guy is again a global consumer, so if he is accessing multiple services, if each service is hosted in a different region, so then that might not work, right? Better. So
no, if a particular user maliciously actually trying to abuse the system, and he or she is trying to actually access the
To have
system
a
from
global counter,
different.
right? I mean, somewhere we need to, at least it may be distributed, but
But the global counter, I mean,
yeah, even
consider
though the data is distributed, we need to, yeah, continue.
but consider the latency here. If you keep the global counter, consider the latency. One request comes from Japan, another from North America.
Yes. So this boils down to the
Yeah,
inventory
so
problem, right?
yeah, so
Kind
there
of
is a
like,
there is a trade. So you have to discuss both the solution with the interviewer in that case.
mhm. Maybe if there's a burst, right, and there's a latency for some transactions, we may be, or when you're coming to the threshold, right, you reached 90 or 95% of your threshold, then they will actually try to make sure that you're reaching the limit, or they will try to or
There is
if
also
the
a
latency
soft
between
limit concept. There is also a soft limit concept. I mean, like I was insisting on hard limit in the example, but like in the soft limit, they can exceed like of certain percentage or certain number of requests beyond their threshold. So like, let's say I'll give you 10% more than what I promised you. So that's a soft limit.
Yeah, to give you one example, right, what Xfinity is doing right now in for internet, right, they have a hard limit and soft limit. So hard limit is once you reach 80 or 90% of the internet usage per month, you will get a notification, correct? Once you use the hard limit before 1.2 terabytes, then you'll get a hard limit or you'll get charged. Maybe something
Yes.
similar. That is not
Yes. Yes.
exactly the rate limiter service in action that we all actually use every day. Is how much of data that we are using from Comcast or Xfinity or any of the internet service or your mobile phone data. They are limiting our data, right? So sometimes
Yes.
we may go a little bit, like if even though your limit is 100 GB, you may exceed by 105 for a second, but after that you won't be going any further once all the data centers are in sync.
Yeah, with the mobile, with the client mobile, it's easier, right? Because only one single client. This, impose
Yeah.
this one kind of problem. Even with soft limit, right? Even with soft limit, and you have multiple data center, you have to subdivide the soft limit to multiple, data center, because the aggregate of that soft limit at each data center will be the total, right?
Yeah, I think it will be simplified. I mean, like if the yeah, it depends on. Sorry, I don't know. My voice is echoing. So it depends on again, like how if you keep your service like rate limiter like or API gateway distributed, so that means that your service um, need to have a setup of like whether it's a single leader or multi-leader of that kind of a setup, and depends on who calls the shots, right? Like in the you can always check with leader for those, but again the leader will be overloaded. So as far as I know, like API gateway is not as much as distributed like our actual services. I think it's maybe, yeah, I don't know, like maybe we need to learn or deep dive on API gateway service sometime.
Hey Naga, how about this for the design? Basically, instead of maintaining all the windows and the timestamp, how would we simply create the keys and store in Redis with the TTL? For example, let's say if we have a limit per user per endpoint, it can only make 10 requests in a minute.
Mm-hmm.
So we're creating a key like endpoint underscore the user ID with a TTL of a 1 minute. And then when the new request comes, we just call the Redis and we check how many keys are there. So if it is basically more than 10, we don't allow it. If it is less than then we simply allow it. So all that timestamp we don't have to care because that will be taken care of the Redis TTL.
Okay, so let's say we have 100 keys for each client for per URI.
Yeah.
So what happens when the request comes?
So we are creating keys. So basically on per URI per user, like whatever the use case on basis of that. For example, I said key I have to create. I'm allowing any user ID to any user ID can make make call to a particular URI only 10 times in a minute or 100 requests in
No, no, no,
a
no. But like, how do you clear or how do you keep adding those keys? Like, let's say in a sliding window
So
fashion. So how do you, when the request comes, do you delete those key or?
no, I don't delete. I add the keys with the TTL key. Okay,
Uh,
for this key, it
uh,
should be Yeah.
Okay.
So it is.
Yeah.
So you keep adding the key, and
Yeah.
but you're offloading the TTL responsibility to
Yeah.
Redis.
Yeah. Yeah. Yeah.
So
Yeah.
okay.
Exactly.
Yeah, I mean,
But
like if
but with Redis also, it's if it is distributed and internally it uses a leader
yes,
follower, then
yeah,
you on one. So suppose you are reading it from two different machines. At one machine you say, okay, it's good request, we can allow it, and on second machine you can say, oh, we should limit this. So it's difficult actually even with Redis cluster.
Okay.
yeah. I mean, like like all the databases that have TTL, like I think DynamoDB also supports. So you can keep storing, but the challenge is again it internally would rely on either single leader replication or multi-leader, so or leaderless quorum based. So each one will have again its own advantages and disadvantages, and there are some
So,
concerns and edge cases.
so I didn't understand why it will be accessed by multiple machine. We are saying that it will be just one API gateway service, right? We are saying that that will scale and then there might be multiple
Yeah,
API.
yeah. If the API gateway is like a global, like I mean, like one API gateway service is again
Right, a
it's a
bottleneck.
point of failure, right? So
Right.
so you will always have another one. So at
At
least
least,
at the minimum, yeah.
yeah, at least we'll
But the
separate application.
sorry, go ahead, Pankaj. You're trying
I'm
to say.
saying that at least for avoid the single point of failure, we have to configure replications, and then
Yes,
again
yes.
distributed, and we are back to zero.
Yeah. So yeah, that replicated one would be ready to take over this one when something happens. But like you still have to some requests will be failed and client would end up retrying. So in those period.
And we didn't talk about concurrent isolations at all here. So I was thinking even a single user can log in from different machines. And suppose there's a user and he just pass on his user IDs in the family, and his family now using it, using the service. So even in such cases, we might have same like request from same user at same time, and such cases also needs to be handled somehow.
Yeah,
Yeah,
I mean, like I
that,
didn't extend that because it's again like there will be IP address similar concerns.
Yeah,
So I was just trying to get to some basic
yeah,
level
just bringing
because,
another
like,
point. So
yeah,
that
yeah, it's a
also
good point.
might
Yeah,
we have to consider such cases, and then the problem is different because we have to
yes.
somehow serialize this stuff, and again, a lot of things to discuss there.
I think that is the question what Leon raised, that I mean accessing it globally from different location.
No. It globally, that's across the globe, and for one location that's different. But
No.
yeah,
Across the globe
yeah,
means that now.
globally, exactly, the behavior would be same. I agree. Yeah.
Hmm.
Okay. Anyone else wants to bring up anything, or like we can conclude?
So in all of these solutions, we are agreeing that there is additional latency, right? So when we talk to the centralized counter, we are agreeing that we are incurring additional latency. So is this something acceptable wherever whoever using this in practice? Uh,
Yeah,
is it something?
generally it should be within milliseconds or nanoseconds. This rate limiter it should be behaving because you should not add a lot of latency with API gateway proxying itself, because the actual request would be served by the service. So it depends on like if that API. Generally, I think it's within this proxying is within nanoseconds in a real world.
But I believe you're going out of the box, right? So I don't think it will be nano. It will be in milliseconds.
Yeah, it
Yeah,
will be
yeah, yeah.
millisecond
If it's
and
a distributed, yeah, in a distributed setting, yeah.
yeah,
So
and
it'll be
during the
milliseconds because
Yeah.
yeah,
So
even if you have to, like if it's a request from one region like North America to Asia Pacific or Europe, yeah, it'll at least take some milliseconds. So
So
maybe it will.
again, another question I had related to that was like, if we dependent on the third-party services like APG or some other, how will they make sure that they are nearer to your data center? Because
I, I
they could be in their own. It's not a like a, it should be like a hosted service, right? Or they are
Yeah,
shipping
it's hosted.
the.
I think you should be able to choose now because all of them operate on cloud. You should be able to choose a region, primary region, where it's serving the customers.
Yeah, but
So
because the practical example I could say is like if my data center is sitting somewhere in Buffalo and
mhm.
Apogee is sitting somewhere in New York, even there is a, even though the region is same, there could be additional latency because they are in two different cities. There is a more network latencies, right? So in that sense.
But I think Apache or like all the API gateways may have some special setup. Like if you want like to be internally hosted gateway, you can still do that. I think.
Does people actually use that when they use the in-premise services, say like their own data center, so they actually go and rely on these external, or they actually request them to or get something in the same premise?
Yeah, so for we have like APG external and APG's. APG external is SaaS, right? Where customers, and APG internal on-prem, which are
Okay.
residing in our own data centers. External ones we have like 50 odd machines from APG or SaaS services, which we are actually we don't know where they are, but they're we just have one URL and they'll point to that 50 distributed machines across the world.
So,
So we'll
in that
configure
setup,
that.
in that typical setup, so how much latency do you anticipate? Additional latency because of this?
We don't. It's very fast. Actually, I didn't never noticed any latency. It's super fast. Maybe they optimized it. Maybe at least for authentication, they optimized the networks and they have dedicated lines, so we didn't see much latency even during the heavy traffic.
Yeah, so that's good to know. Another question related to this I had was like, so we decided on in this solution, we decided on this distributed counter, right? Is this something which is out of the box available from Memcache? Because there could be multiple boxes talking at the same time, like a concurrent request happening. Uh, how are we making sure that our counters are thread safe? Or because I don't think if we are going with Redis or something, I don't think Redis is.
I think
It's a,
I think they
yeah.
have. I think Redis also has concurrency support. I think Ramya was also talking about concurrent hash map when
Yeah.
she planned to use it in a solution because
Yeah, you can lock row by row instead of locking the whole table itself. The concurrent hash map generally provides that approach, at least in Java. So Redis also will have something similar to it. Yes.
Okay, yeah. So the time that once you introduce logs, it's always a contention, and you are kind of
yeah, the moment
holding.
you
Yeah.
use logs again, you I mean like it's a performance again. So I mean like, but it will be the same client, right? So for the same client, you generally don't. I think at any point in time, the a client request is again one only, right? You're not going to one client is not going to write other clients counters.
Hey Naga, as I was thinking, as we were discussing, right, somebody in the audience was talking about TTL concept on the cache. So I was thinking a little bit about that. I have a question about it. So if we use that TTL thing in the cache, right, we will keep writing. So the cache will no longer be just for read, it will be for write also. And looking at the requirement, every second we are going to make these changes, right? Is it okay to make so many writes per second or on the cache? Like I remember, if you hit the cache too quickly and if you're making too many writes, can that be an issue?
I think cache is you can manipulate, right? You can write as much as possible, but I think you need to limit the number of writes. So I think
Yes,
in your
for
fixed
writes,
window approach, you are only doing it occasionally. So if you
correct.
take a minute or per second once,
Right.
so with per that second, like there are so many thousand milliseconds, right? So you're only doing once per second or once per minute resetting. In a sliding window approach, you still need to I think when you slide the window, you need to decrement the request that happen in the earliest time second, not across, right? It's just still one.
Mhm.
So it's a constant throughput. So
And even with the TTL in the cache, are you rely on the cache to delete the entry, or
That's
you gonna
correct.
have another process, another thread to run through it and find
I
which one
think,
is
No,
yeah, there should be
TTL is
another
cache.
thread, I think.
No, in TTL, like in the cache, at least this is how it happens in Redis. I don't know about the other caches. So there will be a TTL concept, time to live concept, right? So as soon as the TTL hits, it is the responsibility of the cache. It will just clear out all the contents on its own.
Yeah, it's supposed to, but like I'm talking about how the TTL will be implemented. So you should
I see.
rely on system clocks to see, like at least you should track, right? What was the last I mean, like when this TTL was stored, so that like let's say time to live of 1 minute, then you again delete that after 1 minute. So when you say time to live of 1 minute, somewhere like you should rely on system clock from now remind me in 1 minute. So when I get that signal of 1 minute, then I go and delete this. So
yeah,
there should be some watcher which would be Redis or any system implementing this TTL should rely on this again time.
any time you delete the entry, there will be a lock and unlock on that hash table.
Mm-hmm.
And if you delete it many times, that's going to be, keep it busy a lot. So, you have to plan. And if you like periodically delete it, that means you might miss, certain entry.
I think theoretically it looks like, I mean, that the cache can work, but I think this TTL kind of thing cannot help here. I don't think so. I mean, you can use that millisecond level TTL, and that will also depend
Yeah,
on
I think
that.
that will be, yeah.
Yeah, that was what I was
Just
like my
using the
question.
data structures by storing the UTC
Yeah,
time, like maybe faster than using a TTL.
and here you are on the mercy of the system, that when the
Mm.
thread who has the responsibility to clean up will get the time slice to execute that. And there may be other things, maybe at that time some garbage collection is happening, so that will be delayed.
Yeah. So it's basically, yeah, in system design world, like whenever we abstract certain feature to some other component, we should know what that component is doing to implement this and be aware of its bottlenecks or trade-offs. So as long as you're willing to compromise that, you can still offload that responsibility to that component. And yeah, as long as you'll be able to convince that, like if you're in an interview, what that is and why you made certain decision, that's good.
So
So
in general,
going
how
back to you say at the beginning, Naga, going to have a single, global API gateway. That would be, I think if we allow to go that way, that would work, right?
Yeah, it will work. Yeah, you can have a single API gateway and one standoff. And if that API, like as an organization, if you have all the services on-prem, and you just have two API gateways, one standby and one serving the traffic. I mean, like if your load is able to be handled by one API gateway, I mean, like which I think they can most part like work for small to medium organizations. So, but like for a larger organization, like serving so many like millions of APIs.
So how
Yeah.
about this? Like
Mhm.
even if we have multiple API gateway services, right? We don't have the exact like each API gateway service will have its own cache instead of having a global cache. Every gateway service will have its own cache, and we divide the responsibility instead of having like, for example, if we have 5 caches, right? All of them will not have the same contents, so that way we don't have the problem of synchronizing the caches. Let's say A to F one cache will have, then remaining another, like we'll split it up like that, or based on some random number, we can decide like what some basis, so that all 5 will have different data, and all gateway service is independent on its own, right? Now we don't have that synchronization issue at all. Each one behaves on its own. Can that not be acceptable?
No, but like the API gateway, like even if you divide or like if you shard based on the APIs,
Mhm,
there are like situations like if you again keep, so the API gateway can be in North America region,
mhm.
but it's serving the APIs for some other Europe or Asia Pacific. So which is not good. So again, you need to have this concept of regionalized API gateways. And the moment you have that, you have the clients coming from all over the world. And again, like there.
How about, so in
Mhm.
that situation, how about we shard based on, like instead of A to Z thing, we shard based on the location itself? Then that will be more optimal, right?
But then you're saying that, I mean, for each location, you will have a separate IP address. So
Um,
DNS service will give that separate so that you can direct the request to a different gateway. Is that
yes.
you're saying?
Not each location, but like a set of locations. Yes. Like we can make a radius
So
and say,
let's say, yeah, I mean, like to your example, so I have the same API being served in North America as well as Europe,
mhm,
and the client, as a client, I'm actually invoking both North America API gateway as well as some requests are going to Europe. I don't know if
mhm.
that is possible, but
But now
generally we don't have that scenario because I think a client normally uses one particular API gateway. So maybe these cases are not so regular.
yeah, think about the problem here in that what just Pankaj raised that. So now it's a global. So now the someone shared their credential with their friends or family or right, and
Mhm,
one request comes from the North America for the same user.
mhm.
Right.
And
That's
now
why I'm saying if it is not at all global, like each API gateway service has its own cache, then we don't run into this issue, right? Like if
yeah
we have,
yeah.
But you
Let me
are
complete.
allowing double the requests in
And
that
the
case.
second request for the same user coming from the Japan. So that both will go to the different data center now.
why will the same user request go to two different gateway service?
Because you split it that based on the location, right?
Correct. So one user can be there only in one location, right?
No, it cannot if they share the credential with others.
Oh, now you're saying it might be based on the credential. Okay, yeah, that is,
Because your rate limiter is based on the user, right?
yeah. Okay, yeah, that makes sense. So
Y-
then we need to say user and location. Okay, yeah, that will get complex.
How
Yeah,
come
user plus IP address is also a
credential?
combination. Yeah.
Yeah.
We are, I think, talking about a corner case, user sharing its credential.
Yeah, it's not regular case, but yeah,
That's true.
that's
Yeah.
correct.
Okay, so other thing, I have seen like any rate limiting solution is not like they give a window of 1 hour. They are generally very small, like a minute or a second even sometimes. It's not like so. So if there is some rate of error also, it could be okay because our tokens will again reset another second or a minute.
Yeah, that's a good point. Yeah, but because like whatever issues we are facing is for a very short amount of time, the latency. Okay.
Okay, I think this was a good discussion. We were out of time. I just realized that.
Yeah.
Okay,
Stop the recording.
let's stop the recording. Thank you. Just a minute.